what's called a base e, and it's a natural base. And we're going to get into logarithms and stuff like that, but the e is tied to those. But we'll cross that bridge when we come to it. So the constant e has certain mathematical properties that make it a convenient base for exponential functions. Here. Okay. E is an irrational number like pi. It's just applied differently. So that is when we did the compound interest formula 2 days ago, where you had P, N, R, and T. The E is going to take the place of that whole expression, except for the T value. So the 1 plus 1 over N to the nth power. So it's going to be substituted in for that. So it's a similar formula. It's actually just a little bit simpler. All right, but it's going to be compounded continuously. So you're going to see the word continuously instead of monthly, quarterly, annually, semi-annually. So this value is equal to an irrational number decimal 2.7182818, and then it keeps going with no particular pattern. But it looks like an exponential function. So the graphs display the same general characteristics as other exponential functions. So it will approach the asymptote as it approaches negative infinity. It will approach positive infinity as x approaches positive infinity. So it's the same shape we've been dealing with. The y-intercept is still 1. Okay, so nothing has changed there. We're not actually graphing them today though, but you're going to be using the graph in the calculator for the last bit of what we're doing. Okay. So you can calculate continuously compounding interest by using this formula. So if you want to either highlight it or box it, we're going to use it on the word problems. A equals P times base E to the RT power. Okay, where A is the amount in the account after T years, P is the principal amount invested, and R is the annual interest rate. So base E, it's actually a button in your calculator that you will need to use. And some scientific calculators, like the very basic operations, have them, some don't. But it is automatically on those TI-84s. But we'll get to that in a moment. What we're going to start off with is actually just simplifying these expressions using exponent rules. So if we have multiple base e's being multiplied, how do you combine those exponents? You add them. Okay, so what's 7 plus negative 2? 5. So this would simplify to e to the 5th power. Okay. How would we simplify b? Now the negative 3, and some of you mumbling, okay? Negative 3 needs to be raised to the 4th power, as well as base e to the 2x. So you could split it apart like that, but that 4 applies to every base in there, including a constant. So what is negative 3 to the 4th power, since we all have calculators? 81. And then these two, you would multiply these exponents like we've been doing for 2 days. So that'd be e to the power of 8x. So 81 e to the 8x power. So when you're simplifying these, you treat e just like you would a variable. You know, it's technically a number. And then c, how would we approach that one? What do you do with the big numbers? Divide? Does that go in evenly? 42 divided by 14 is 3. What do you do with the exponents on the e's? Subtract. So 7 minus 5 would be 2. So 3e squared. Yeah. So these bottom 3 are similar. Anyone tell me the answer for D? E to the 8th. It'd be 4 plus 3 plus the 1 that's here. So 4 plus 3 is 7, plus 1 is 8. What about E?
1,296 today.
So we would do 6 to the 4th power and E squared to the 4th power. So that's where those would come from. And the last one. 60 divided by 12 is 5. And then 6 minus 2 is 4. Now those are exponent rules you have been applying since you took Algebra 1, 2. So those will still apply if they come up. Hopefully we find them easy. Any questions on any of those 6? So a handful of your homework problems are like that. Make sure to copy down the original problem. All right, now getting into that formula up here that I boxed. So this is what we're going to be using. We're very chatty. All right, Lexi deposited $1,500 in a savings account that pays 2.5% annual interest, compounded continuously. So instead of quarterly, monthly, annually, semi-annually, weekly, twice a month, anything that we had the other day, continuously is going to mean you're bringing in base E. That's the only difference between this formula and the other one. So after 4 years, what will be the balance in her account? So your formula you're using is P times base E to the RT power. And that's R and T. So we're going to need to figure out each of those things before we plug it in. So what would P be?
1,500.
Initial amount, 1,500. E is just E. So you're not filling in anything for that. That is a number. So that's already there. What's R? And now we write 2.5% as a decimal. 0.025. Okay. If you're not sure if you got it right, take the percent of 2.5 and divide it by 100 in your calculator, and it will move the decimal for you. So you divide it by 100. T.
4.
4 years. So E is going to be a button we push in our calculator. So that is not a variable. It is a number. So when we fill this in, we're going to have 1,500 times base E to the power of 0.25 times 4. Now when you enter it in the calculator, unless you find what this is first and combine it, but if you put it in the exponent, you need parentheses around it unless you have a newer version of the calculator. So this is a more condensed version of the formula we used 2 days ago for compound interest. It's just because it's continuously, it's not periodically, it's continuously. So going to your calculator, we're gonna type in that whole thing, 1,500. Does anyone know where the E is?
Division.
The E? The lowercase e.
It's there, but then there's also like the EX.
Okay. It's actually e to the x power, so it's the second option. This is called a natural log, and we're gonna get there in a second. Well, not in a second. 2. Okay. Second ln. Okay. So right next to 4. So it will put an exponent. So yes, technically there's an e on the division, but it's not the same e. And then if you have one of these, you can just do 0.025 times 4. But if you want to be extra safe, put parentheses. If you have an older calculator, you have to use parentheses. Okay. And close your parentheses. And we round money at the nearest hundredth. So what would that be? 1657.76. So the only thing that's changed is just the formula setup because it's compounded continuously. Questions? Okay. I want you guys to try this one. Let's see how we do. Okay. Everybody else is second catch up. You should be trying this on your own. Same formula. You deposited $3,000 in an account that pays 5% interest, compounded continuously. So that word continuously signifies the base E. Yeah. And then how much will you have in the account after 3 years?
Was it 5% going to be 0.05?
Just 1 0. And if you were ever not sure, since you're taking the percent out of 100%, that's why you do 5 divided by 100, which should be 0.05. So if you're ever not sure, divide the given percent by 100. Who's got an answer?
I do.
Oh yeah.
Yeah. 3,485.5.
0. Is that what we're getting? Good. So plugging that into the formula, P would be your starting amount of 3,000. R would be 0.05. T would be 3. So 3,000 times base E to the power of 0.05 times 3. So that is what you would put in parentheses in your calculator. Does anyone need to see how that's done, or are we all okay? So if you need the keystrokes to find your E, it is second. And then this is called natural log, but that's lowercase ln. That's right next to 4. So you hit second first and then that one. Okay. Any questions? So if you don't have a graphing calculator, check your scientific ones to see if some of them have that button. It's just applied differently, so you have to be careful if you do that. Okay. What we're going to do now is solve Mason. Mason. I don't want to see it anymore, or it's going up there. So, oh wait. So if we are solving, you were just solving, that's what you turned in. 5 equals 2 times e to the x power. You cannot make the bases the same when one's an e. So this is applied differently than what we were just doing. So what we're going to do is use the graphing portion of the calculator. So for this part, you're going to have to use a graphing one. I'm going to write out what we're going to do first, so you can refer back to it if you need to. Now, if these two are equal, this is going to be a line, this is going to be a line, it's just a curved one. We're going to see where the two intersect, and it's the x-coordinate that they have in common, is what we're trying to figure out. Okay. So you are trying to solve for the x-coordinate of the intersection. That will be our answer. Okay. It will likely be a decimal, just FYI. Okay. So what we're going to do for this, and I would encourage you to write it down at least for this one, and then we're going to duplicate it on the second one. So in y equals, on one of the lines, we are going to plug in one side of this equal sign. So y equals 5 will be one of the lines. And then below it or above it, doesn't matter. We're going to have 2 times e to the x power in another one. And we're going to do this in the calculator. Okay. So if you're solving for these involving a base e on one side most of the time, you're going to enter in both of these. So let's go to our calculator and do that. So in y equals, one of the lines is a 5, just by itself. And then we have 2 base e to the x power. Okay. It does not matter which one you put first, as long as you have both. Okay. Are we good? Yeah.
For this calculator, when you press the E, it brings up to like, and then the arrow and parentheses.
The arrow is an exponent. So yeah.
Okay,
So
it's
just put an
the
X
same
there.
thing.
Yeah.
So it's like the same thing as that.
Yeah, it's just an older software. All right, go ahead and graph it. So if it's a single number, it's going to be a horizontal line. So that's where my blue one's coming from. But if you have an older one, they're both either gray or black. So the other one's a curve. So you need the x coordinate of that intersection. You're going to do that the same way that we did some other things earlier in the year. It's going to be on that calc menu. Okay. So calc is the blue option for trace. So we're going to hit second, trace. And we're finding the intersection. So what thing are you going to choose? intersect. Okay. So you're gonna choose 5, or just arrow down and hit enter. Okay. Now I'll write this on the screen so you guys can write down, but if you want to hit second, trace, intersect. Okay. Now, in the past, they've had to do right bound, left bound, guess. That's not what we're doing this time. Now, first curve means the first function. So you'll notice it's on the blue line right now. As long as it's on one of them, you can hit enter. You don't have to move it around at all. So first curve means first function, enter. It will jump to the other one. So it's identifying which 2 functions you want to see if they're intersecting. So second curve, enter. Guess, you need to move it as close as you can to that intersection that you're trying to see. Because sometimes there could be more than one depending on what type of function. So I can get pretty close, but depending on the pixelation of yours, you may not be able to get as close. It's okay, as long as you're in the ballpark. And if you hit enter, the intersection coordinate is at the bottom of the screen. Okay. It's just the x value. So let's do the nearest thousandth. What would that be? 0.916. Okay. So x is approximately 0.916. So again, I'll briefly write up here. So after you do these and you hit graph, you're gonna go to second, trace, which is the calc menu. So if you wanna write down what buttons to push, and then it's option 5, which is intersect. Well, not interest, intersect. And then it's first curve, enter, second curve, enter, guess, enter. Do I need to write that down? The option 5 on that list is intersect. So you can either hit the number 5 or arrow down to it. So it'll be the first curve, you'll hit enter. I cannot spell today. Second, enter. And then you are guessing where it intersects when it does guess, and then you hit enter again. Okay. And then you're using the x coordinate. The y does not matter in any way. Okay. Because you're solving for what x is to make it equal to 5. So that's where it's equal. Okay. So question on that one? So you're gonna do the same process on this one, and let's see how we do. So you guys do it on your own, but it's the same process. So one of yours, I'll at least write this part out. You'll go back to that y equals screen, clear out what you have. One of them, either the first or second, make sure to do a -6, the negative's below the 3. And the second one is -1.5, base e to the power of x minus 3. Make sure to use parentheses if you have an older calculator around the x minus 3. Then walk through that process. So let's see if we can get the right answer. Again, 3 decimal places is usually pretty standard for these.
When I get to the intersect part, no.
So on the bottom of the screen, it should say first curve. As long as it's on one of the lines, hit enter.
It's on like a line that's numbered.
That's okay. Hit enter. It will jump to the second line. Hit enter. And then when it says guess, move it to where the intersection looks like it is. And then hit enter.
So we're like crosses that.
Yeah. So you're just showing it where to look. Who's got an answer?
Riley does.
Elvis?
4.386.
It is approximately 4.386. Now, is anyone way off? The only way you'd be way off is if you didn't plug these in, really, because the calculator does the work for you. So if you didn't put parentheses around the x minus 3, that would throw off your answer. But you wouldn't know because the graphs are going to look fairly normal. Okay. So I'm going to quickly walk through it just for anyone that may have missed it. Guys, we're almost done. So if you got it right, that's great, but I need to make sure everyone's on the same page. So your two graphs, second trace for your calc menu, either arrow down to option 5 and hit enter, or just hit 5. As long as it's on one of the two lines, hit enter. It will jump to the second one, hit enter, arrow over in the vicinity of the intersection. Doesn't have to be super close, but 4.386. Okay. Questions? So we did 3 different things today. Is there any questions on anything we did? Are we all clear on where the base E is? Okay. So your assignment, it's chunked a little bit. So 1 through 9 all, 13 through 15 all, so that does include 14. And then 16 through 21 all. Okay. It's around 15, 16 problems. All right. Maybe 17. But they're all like our examples.